All right, so I'm continuing with today's topic, a continuation from yesterday's topic, which is finding the area between two curves. This example is going to be slightly different from yesterday because now we're talking about doing this with the respect to the y-axis. So that does affect the way that you look at the problem and set up the problem, but the basis of it is still the same. All right, so I'm finding the area between the blue and the green curves. So this section right here and this section right here, these are my function names, and the other one is down here. So I'm gonna be setting this up on the board, and you're gonna see how we set it up. And remember, this is gonna be with respect to the y-axis now, so it's gonna be slightly different than the other one. So what I did first was I just kind of drew something on the board to represent the same diagram that I have on my computer screen. I also wrote out every intersection point. So every time these cross and hit each other, I wrote down their locations right here so I can see it. I also labeled each graph. So the graph that is going in this direction is named up top, and the one that's coming in the other direction is named here at the bottom. All right. So all we're trying to do is figure out the areas of the enclosed parts. So that's what I'm about to start on the next slide. All right, so I'm going to set up the first little area here, which is the one that's going to fall in this area, and I went ahead and labeled it right and left, so that when I start to set up my integral, I know which part to write on the first and which part to write second. Now remember, I'm setting up my integral to go from -1 to +3 because this dot drops as low as a -1 and it rises as far as a +3. So that's where that comes from. Now, if I do a right minus a left, and I'm doing this with respect to the y-axis, then all I got to do is make sure whatever the function is that's on the right at that moment goes here. Whichever function on the left at that moment goes here. So the part that's on the right is this one. So that's going to be the first thing I write down. All right, so I integrated from -1 to +3. There's my function on the right minus my function on the left. All right, so I'm going to go through a couple of more steps. I might skip those and get back down to the calculus portion of it, like in 2 steps. So I went through a simplification process to get me down to right about here. All right, so I have 30 plus 26y minus 6y to the second minus 2y to the third. Now from here, I did my antiderivatives. There's my 30y. There's my 13y to the second. There's my 2y to the third power. And this one definitely is my y to the fourth over 2. And remember, I'm going from a -1 to +3. I'm going to go ahead and plug in those numbers and do my subtraction. I'm going to write the result down in 1 second. All right, this part required like a lot of like arithmetic and stuff that I really didn't need to get into at this moment. So I went ahead and did the antiderivative right here, set it up on paper first, and then I punched it in from there to see what I get. So 128 is the area for the part that we're trying to figure out so far. So right now we have an area of 128. Now all I have to do is set up another integral to figure out this area. All right, so now I'm focusing in on this area. Remember, so this part right here goes as low as a -5 and as high as a -1. Therefore, I'm going from a -5 to a -1 on the y-axis. So that's where that comes from. Now, remember, the function on the right, remember, the one on the right is on the right at that moment or in that area that I'm focused on. This one is on the right, which happens to be named this. So that one comes first. Then I do minus the other one. So that's how we set it up. We know where we're starting and stopping, left minus right with respect to the y-axis. That's what all that means. All right, so I went through a simplification process where I combined everything together. So I'm going to skip over that part and go straight to what I got after I simplified. So 2y to the third power plus 6y squared minus 26y minus 30 with respect to the y-axis. Now remember, we're integrating from -5 to -1. And these are my antiderivatives now, y to the fourth over 2. This one comes down as 2y to the third power. This one comes down as a -13y to the second. And then this one is a -30y. So I'm going to punch the rest into the calculator. It's going to give me what that number is also. And that number will represent the next area that we're looking for. All right, so my calculator cranked out another number for me, and that's 128. So what happened with both areas is that I got 128 both times. And if you get the total is 256 if you add that and that up. So the answer will be 256 square units because we're talking about the area. Now, one mistake, please don't make. Just because you figured out the first one was 128 doesn't automatically mean the other one will be the same thing. This example so happened to give us a 128 both times. All right. That is not a rule. All right. So you do have to set up each one separately because you never know what each one is going to give you when you get finished calculating. So the final answer here will be 256 when I add up both of my 128s on the board. All right, so that's the only example I'm going to do for today. I think I'm going to be working on another one similar to it, this time maybe using a computer presentation to kind of lay everything out. I just want you to see both examples from yesterday and from today where we found the area between two curves, one with respect to the x-axis, the second one with respect to the y-axis. Yep, so here we go here. There's my YouTube channel. Type in BJ Jeffers, you'll find me there. You'll look for a picture similar to this one, and that's the one you'll be subscribing to. So if these videos are helpful, I always come back. I'm always putting things up each day when I come to work. If you have questions, you can always leave a comment, and then that'll give me something to work on too. I do like giving myself challenges.